In this video, we will learn how to solve inequalities. Example 2a reads, x plus 7 is less than or equal to 9. I cannot make the decision yet as to which direction I'm going to shade until I leave my variable alone, until I isolate this x. So that I'm going to move this plus 7 to the other side. Just as we've done before in equations, we're going to move the 7 by subtracting both sides by 7. Then the 7s are going to go away, leaving me with x on the left side, and then 9 minus 7 will be 2 on the right side. Now we look at the inequality. Since I am adding or subtracting, the inequality is not going to change. So we're going to leave it be. So what does this mean? Well, remember this symbol means less than, and we do include the 2 because of this little line down here. Or since x is on the left side, I can just look for the symbol in the number line. This looks like an arrow that is on the left side, so then I'm going to shade to the left side. So I find my 2 and I shade to the left side all the way to negative infinity. Because I am including the 2, I'm going to place a square bracket. When I write my solution, I read the number line from left to right. So I'm going from negative infinity all the way to 2. I am including 2, but infinity always takes a parentheses. And this is my solution. Let's try B. Now you see how this time the variable, the x, is on the right side. We could leave it there if we want, but it's better if I put it on the left side just so that I can use those arrows in the number line to help me in case I forget. So I'm going to flip this whole inequality. So I'm going to write the 3x first and then the inequality. You see how the inequality is opening up towards 3x, so then I'm going to place an inequality that is opening up towards 3x, and then I bring my 6. I still cannot graph this inequality in my number line to find the solution because this x has a 3. This x is being multiplied by 3, so then the opposite of multiplication will be division. So we're going to divide both sides of that inequality by 3. So 3 divided by 3 is 1x, or just x. On the right side, 6 divided by 3 is 2. And I am dividing, but I'm dividing by a positive number. That means that the inequality will remain the same. Remember, the only time that we change the inequality is when we divide or multiply by a negative number, which is not the case here. Okay. So then I check, what does this symbol mean? Well, if you remember, this symbol is greater than. I want all the numbers greater than 2, but since it doesn't have that little line underneath it, I do not include 2. Since x is on the left side, I go look at the end of the number line, which one has this arrow. So it's not in this direction. It's right here in this direction. So that means that I'm going to shade to the right. So I locate my 2. I shade to the right, and to the right I have positive infinity. Since I do not include my number, I'm going to use a parentheses. When I write my solution, I read the number line from left to right, so that is 2 to infinity. So it's 2 to infinity. Once more, since I'm not including the 2 will take parentheses, and infinity always takes parentheses. And this is going to be our solution. Let's move to another example. Here's example 3a. This one reads, negative 2x minus 1 is greater than or equal to 5. Now, because this x is not isolated, it's not alone, but it has 2 values. It has this negative 2 and this minus 1. If you watch the video on solving linear equations, then you might remember that we always move first anything that is being added or subtracted. Since that 1 is being subtracted, I add 1 to both sides. So 1 minus 1 will go to 0, leaving me with minus 2x on the left side, and 5 plus 1 will be 6. Since I am adding and subtracting here, the inequality will remain. Next, that x is still not alone is being multiplied by this -2. So then I'm going to divide both sides by -2. On the left side, -2 divided by -2 is 1. So 1x or just x. And on the right side, 6 divided by -2 is -3. But I have to remember right here, I am dividing by a negative value. And when we divide or multiply by a negative value, then that inequality has to flip. So instead of being greater than or equal to, now it's going to be less than or equal to. So let's start graphing then. This one right here is less than -3, and we do include the value because of this little line underneath it. So I go to my number line, I locate -3 right here. It's less than, so I'm shading to the left. Here is where the inequalities match. You see that? Here and here. All right, so I go all the way to -infinity. So my solution, I'm going to read my number line from left to right. So then that is from -infinity to -3. Since I do include the -3, then this takes a bracket. So then my solution at -3 has a bracket, and infinity is always a parentheses. And here's a solution for this inequality. Let's try another one. B reads 5 plus x divided by 7 is greater than 10. Now, I don't know about you, but I know that a lot of people don't usually like working with fractions. So what we're going to do first is eliminate the fraction. The way that we eliminate the fraction is by looking at the denominator and multiplying every single term by that value in the denominator. In this case, it's a +7. So I'm going to multiply every single one of these by 7. From left to right, 5 times 7 is 35. Don't lose the plus. The 7 with the 7 will get eliminated, leaving us only x. And then on the right side, 10 times 7 will be 70. Because we multiplied by a positive number, the inequalities stay the same. So then that remains greater than. Next step, I still don't have the x on its own. I still have this +35 being added. So then I'm going to subtract both sides by 35. The 35s get eliminated. On the left side, I have an x. On the right side, 70 minus 35 is 35. And because we are adding, the inequalities stay the same. So this remains greater than 35. All right, so x has been isolated. X is on its own. So I check the inequality. This is greater than that 35. But since it doesn't have that little line underneath it, I do not include the 35. Let's go to our number line. Notice how this time the number line is not labeled like the previous ones. That's because this is 35, and it would have been quite difficult for me to create a number line that is numbered from 0 to 35. So what I'm going to do, I'm just going to select one of these tick marks and label it 35. So let's try that. I'm going to label this right here in the middle, 35. And I know that this is greater than, so then I'm going to the right side, because right here, this inequality matches this arrow all the way to infinity. Remember that the matching of the inequality to the arrow only works if the x is on the left side. The next thing, since I am not including 35, I'm going to place a parentheses. We read our number line from left to right to find our solution. So this thing is shaded from 35 to infinity. We are not including 35, so we place a parentheses, and we always place parentheses around infinity. And this becomes our solution. Thank you so much for watching, and I'll see you in the next one.